Okay, so we are doing the integration series, and now we have the question of the 13 number question, that is integral of 10 to the power x to the power 9, 10x to the power 9 plus 10x 10 to the power x ln 10 and divided by 10 to the power x plus x to the power 10. Let's see how we can do. So first of all, we will take this denominator part. We will assume this denominator part as 10 to the power x and x to the power 10 is equal to t, and then we know the differentiation of this. We know the differentiation of this will become 10 to the power x log, I can write it as log 10, correct? And this will become what? 10 x to the power 9 dx. This will become dt, right? So we are finding the differentiation both the side. This will become 10 to the power x log 10 plus 10 to the power. If you see it, no, when we have taken the denominator as t, the derivative of it is in the numerator. So we know one of the properties that if we have this kind of integral f dash of x, f of x, then we can write f dash of x divided by f of x, then we can write as log or ln f of x, correct? So we can write it as ln f of x. So by using this property, we can directly write the answer as, this will become ln and 10 to the power x and plus x to the power 10, correct? And correct. So this will be the final answer for this. Ln 10 to the power x plus x to the power 10 plus c. This will be the final answer. Now we will moving to 14th number problem. Let's see what is the problem of 14th. Let's see what we have problem of 14. Okay. Now we have problem number 14. Let's see what is the problem of 14. Problem number 14 we have is integral of x square divided by 1 minus square root of 1 minus x to the power 6 dx. Right now, so in this kind of problem, you see in the denominator we have a square root of 1 minus x to the power 6. So what we will do, we can write it as x square, and this will be, I can write it as 1 minus x cube whole square. Now what is the benefit I will have by writing of this kind? 1 minus x cube whole square. Now I can assume x cube as t. X cube I can assume as t. If I assume x cube as t, then we know 3x square dx is equal to, it will become dt, and x square dx will become what? dt by 3. Now if I replace all this in the first equation, in the first part, so I will get x square dx is equal to dt by 3. So 1 by 3, this constant part has nothing to do with integration, so we are writing 1 by 3 dt dividing by 1 minus, and since I have assumed x cube square, so this will be what? 1 minus t square, correct? So it becomes like what? 1 by 3 dt 1 minus t square, and that we know that sine inverse, we have dt upon under root of 1 minus t square, and that is nothing but sine inverse of t. So this will become what? 1 by 3 sine inverse t. But what is the value of t we had taken? T initially we have taken as x cube, so the answer will become sine inverse x cube plus c. So this will be the final answer for this, right? Because t we have already assumed here, x cube is equal to t, so this will become sine inverse t, and that is x cube, correct? So this is the final answer for this. Write it down, and then we'll move to the next problem. We'll move to the problem of 15th. Okay, I'm erasing it so that I can do the problem number 15. Problem number 15 is, let's see what we have. The integral of tan 1 by x divided by x whole square dx, right? So we have integral of tan 1 by x upon x and whole square dx, right? So let's see how we can do. So the first thing we'll take as no, we will assume 1 by x is equal to t. If I assume 1 by x is equal to 2, we know the differentiation of 1 by x will become what? 1 by x square dx is equal to dt. Now I can write 1 by x square. 1 by x square I can write 1 by x square dx I can write as minus dt. Or when I replace it, not tan 1 by x. So this will become what? This will look like tan t and 1 by x square. This part 1 by x square dx will become dt. So I can write only here. This will become tan square t and minus will come here and this will be correct. So this will become tan square t. Now tan square t can be written as what? Tan square t can be written as secant square t minus 1. Tan square t can be written as secant square t minus 1. So minus will be here only. I can write it as secant square t minus 1 and this will be dt. Secant square 1 minus and this will become dt. Now secant square integral, no, we have to do the secant square integral. So we have to do it. Wait. This will become what? Minus tan t and the integral of t will become what? The integral of 1 will become t. Now it is fixed. So secant square t will become what? Minus and this will become tan t and minus it will become minus t. And now the replacement of t is what? The replacement of t we have is, this can be written as minus, this will become plus. So minus tan t plus t and plus c I can write. Now the how we have replaced the t, this can be written as minus tan 1 by x and plus, this will become 1 by x plus c, right? So the final answer will be minus tan 1 by x plus 1 by x plus c, right? Now we'll move to the 16th problem. Okay, write it down and then we will do the problem number 16. Let's see what is the problem number 16. Problem number 16 we have is integral of 1 by x square root of a square x square minus b square and here it is dx. Correct? So see, it is a square x square minus b square. So first we will start by assuming it now. We will assume a by b x is equal to t. If I assume a by b x is equal to t, now the differentiation of this will become, we know a by b is a constant part, this will become dx is equal to dt, right? A by, and dx I can write as what? Dx I can write as b by a, and I think one of the x I no correct. So dx can be written as b by a dt. Dx can be written as b by a dt. Now see, this dx can be replaced by what? This dx can be replaced by b by a dt and this x can be replaced by what? That implies no, that x can be replaced by what? X I can write as bt upon a. Correct? And similarly, if I want to change a square x square, so a square x square is basically what? B square t square, because b will go. So also one more implies I'm writing that I can write a square x square as b square t square. Correct? So now make all the changes. Dx I will replace by, the integral will change to dx can be replaced by b by a dt divided by x can be replaced by root. The replacement of a square x square b square t square and minus b square. Now the good thing about this, no, b upon a and b upon a will get cancelled. Right, from here I can take common b and b square, and when it will come outside of square root, no, I can write it as 1 upon b, because this b is a constant part, nothing to do with the integration process, and dt, and this will become here t, and this will look like what? T under root of t square minus 1. Now this is the integral we know, right? There is a direct formula for it, that is secant inverse t. This part is what? Nothing but secant inverse t. So I will write it as secant inverse t. But what is the t we have taken? T we have taken as ax upon b. So I will write it as 1 upon b secant inverse ax upon b and plus c. So this will be the final answer in this case. Correct? So I hope this you got 1 upon b secant inverse ax plus b upon c plus c. Correct? Now write it down and we will move to the problem number 17. What is the problem number 17? Done? Okay. Now we are moving to the problem number 17. Let's see what is the problem number 17. I am erasing it. Problem number 17, just see what is the problem number 17. That is the integral of square root of 1 plus square root of x. Okay, so there is one square root inside and another square root. 1 plus root x and inside and square root. Divided by, and obviously there will be dx, divided by the square root of x. Now in this case, we see in the square root it is what? 1 plus root x. So what we are assuming at t, we are assuming 1 plus root x is equal to t. 1 plus root x is equal to t. This part of differentiation will become what? 0. This part will become what? 1 by 2 root x. Correct? We know the square root of x differentiation is, when we will do the derivative of it, 1 by 2 root x, and this I can write as dx is equal to dt. Now I can write dt upon dx upon root x is equal to 2 dt. Correct? Now do the replacement of all this. I can write it here square root of, since we have assumed 1 plus root x is equal to t, so this will become t. Dx upon this part will become what? 2 dt. So I will write here 2 and I will write here dt. Now this is nothing but t to the power half. T square root is what? T to the power half. So basically you have to do the integral of t to the power of half and t to the power half dt. And we know it is simple. T to the power half becomes what? T to the power half plus 1 divided by 1 plus, and this will become, correct? So this will become how much? T to the power 3 by 2, and this will become, here I can write it here. 2 times of 2 to the power 3 by 2, and this is what? 3 by 2 I can write here, 2 by 3. So this will become 4 by 3 t to the power 3 by 2 and plus c. What is the t we have taken? 4 by 3 and 1 plus root x to the power of 3 by 2 plus c. So the final answer will be 4 by 3, 1 plus root x to the power 3 by 2 and c. Correct? So this is your problem number 17. Write down the problem number 17 and then we will move to the problem number 18. Okay, I hope you have written the problem number 17. Now we'll move to the problem number 18 and let's see what is the problem number 18. Problem number 18 is Problem number 18 is integral of x divided by square root of 1 minus x square and cos square root of 1 minus x square. Okay. So one of the part is square root of 1 minus x square and the other part is what? Cos of square root of 1 minus x square and dx is of this. Correct? So this case we will assume this part as 1 minus x square as equal to t. And we know the square root derivative will be what? 1 minus x square is there, no? So this will become 1 upon 2 root. This will become 1 upon 2 root of this part. So square root of 1 minus x square. And since again it is 1 minus x square, 1 is derivative is 0 and this will become minus 2x. So basically not minus, 2 and 2 will get cancelled. So we will left with what? We will left with x dx and 1 minus x square. X dx and minus sign is equal to what? Dt. Or we can write x dx upon this part is equal to minus dt, sign replacement. Correct? Now make all the changes as per the assumption, no? So this will become what? This part of this, no? X dx and this will become what? Minus dt. So minus I am writing here, dt I am writing here. And this will become what? Cos. And since we have assumed earlier, no, that square root of 1 minus x square is equal to t. So this will simply become what? Cos t. Right? So this will simply become what? Cos t. Now cos t, we don't have 1 upon cos t actually, right? So 1 upon cos t, is it cos square t or cos t? No, it should be cos square t. Okay. It should be cos square t here. This part should be cos square t, right? So make the changes, I think. This will be cos square t. So 1 upon cos square t can be written as what? It can be written as secant square t. Secant square t dt. And the integral of what? Secant square t dt will become what? Tan t. This will become what? Minus tan t plus c. This will simply become what? Minus tan t plus c. So this is your problem number 18. Write it down so that we can move to problem number 19. And okay, so one replacement, final replacement will be minus tan t is what we have assumed, 1 minus x square. This will be the final answer. This will be the final answer. I hope 18 is done. Can we move to 19th? Okay, now we are moving to problem number 19 and just see what is 19. Problem number 19 is integral of it is 1 minus cos x dx divided by cos x into 1 plus cos x. Cos x into 1 plus cos x. Just see what we can do. Since is it in the numerator we can see 1 minus cos x and 1 minus cos x. So 1 minus cos x can be written as what? This can be written as 1 plus cos x and minus 2 cos x. So the first thing we will do is 1 minus 1 plus cos x and minus 2 cos x. Okay, it is same thing, right? Cos minus 2 cos x dx. Now see the benefit I will get from it. Cos x here and 1 plus cos x here. So 1 plus cos x minus 2 cos x. Now the benefit I will get from here is the first part of it, I can write it as like this. If I make the separation, 1 plus cos x divided by cos x to 1 plus cos x and minus 2 cos x divided by cos x into 1 plus cos x. Correct? So this we can do, right? 1 plus cos x, 1 plus cos x cancel, cos x cancel and dx. Now this can be written as what? 1 upon cos x minus 2 dx divided by 1 plus cos x. Right? So 1 upon cos x divided by 2, and 2 has nothing to do with the integral now. So first of all, do like this: 1 upon cos x minus 2, and I am separating it all. Cos x dx minus 2, and this will become 1 plus cos x. Is it okay? Now 1 plus cos x we can break into what? 2 cos square x by 2. 1 plus cos x we can break into 2 cos square x by 2, and 1 plus cos x. 1 plus cos x again we can write as secant x. 1 plus cos can be written as secant x, and this can be break as 1 plus cos x as 2 cos square x by 2. When it is 2 cos square x by 2, fortunately this will cancel. And 1 upon cos square x by 2 can be written as secant square x by 2. 1 upon cos square x can be written as secant square x by 2. So the final integration we will have is, we have to integrate secant x minus and dx minus integrals of secant square x by 2 dx. This is the final integration we have done. Now this part, how we can do? This can be written as secant x can be written as ln secant x plus tan x. Secant x can be written as ln secant x plus tan x, and secant square x can be written as what? Secant square x can be written as tan x by 2 and divided 1 by 2. Correct? So I can write it as ln secant x plus tan x, and this will become what? Tan x by 2 divided by 1 by 2. 1 by 2 basically it will go up. This will become ln secant x plus tan x minus 2 tan x by 2 and plus c. Right? Minus 2 tan x by 2 and correct? So I think this will be the final answer, right? Ln secant x plus tan x minus 2 tan x by 2 plus c. Write it down so that we can move to the problem number 20. Write it down so that we can move to the problem number 20. Now we are moving to the problem number 20. Let's see what is the problem number 20. Problem number 20 is, integral of x cube by square root of 1 plus x square dx is equal to given a 1 plus x square whole to the power 3 by 2 whole to the power 3 by 2 plus b square root of 1 plus x square and plus c. In this case, we have to find basically the values of a and b. We have to find the values of a and b, because the integral we have already given that this is the integral part. Only the unknowns are here, a and b. So we have to find here the values of a and b. Let's see how we can do. The first step will be what? We can write x cube as here. We can write x cube as here, x square into x and 1 plus x square this place. So the first part only we are bifurcating x cube into x square into x, and the second part we are doing is, second thing we are doing is x square we are assuming as t, When we are assuming x square is equal to t, no? So what is the derivative of it? X square we can write as 2x dx is equal to dt. If 2x dx is equal to dt, so I can write x dx is equal to dt by 2. So the first part is done, right? First part done means what? I can write this part x square as t and this will be dt. Now this can be written as what? Square root of. So the complete integral will change. Make the complete integral change. So I can write it as 1 by 2 here. X square we have assumed as t, x dx becomes dt and square root of 1 plus t square. So this will become basically t square root of 1 plus t square. Now what I will do, I will in the numerator, no, we will add 1 and subtract 1. We will add 1 and subtract 1. Let's see how it goes. 1 by 2 integral of 1 plus t minus 1 and divided by 1 plus t square and dt. Now see, bifurcate into two parts. We will bifurcate into two parts. So this will become 1 plus t and square root of 1 plus t square, 1 plus t square and minus I will write here square root of 1 plus t square and the complete is dt. Now see, in the numerator we have is 1 plus t and in the denominator we have a square root of 1 plus t square, right? So if we have to make the changes, no, is it t square? No, it should be t only. It should be t only because x square we have assumed t, no. So everywhere make a change, this should be only t. Now this is square root, no? I can cancel this 2 so that it will become what? 1 by 2. This will become like this, 1 plus t square root of t and this let it be like that only. Square root here also cancel, correct? 1 upon square root of 1 plus t. Now just see 1 plus t to the power half. This is basically what 1 plus t to the power half. If you take 1 plus t is equal to u and then find it u half plus 1 and then half plus 1 in the denominator. So basically do it directly. We will do it directly. We can write 1 by 2 and this will become what? 1 plus t to the power of half plus 1. This will become 3 by 2 and in the denominator also it is 3 by 2. And similarly it will go up, it will become minus half. So this will become what? 1 plus t minus half plus 1 minus half plus this will become half and this, right? So 1 plus t to the power 3 by 2 and 1 plus t to the power half divided by half. Now this can be written as what? This can be written as come to this power. So this will become what? 2 will cancel with 3. So it will become 3 1 plus t to the power 3 by 2 and minus this will go up to 1 plus t half and plus c. Now see, t is actually x square. So write it down 3 1 plus x square to the power 3 by 2 minus 2 1 plus x square to the power half plus c. Now you compare it with this. If I compare it with this, how much we are getting? Is there anywhere 2 we have? B should come how much? Okay, so this 1 by 2 was for all. If this 1 by 2 is for all, no, so this will cancel this 2 part, correct? So this will only come minus like this, or minus 1 or minus you write anything. So now you compare because this will cancel this. This is completely for 1 by 2 was for these two terms. So minus it will come minus 1 and I can write here by comparing, no, comparison will give you A is equal to 3 and B is equal to minus 1 because you see all the rest of the terms are correct. So A value will become 3 and B value will become minus 1. So this was your problem number 20. I hope everybody got it. Write it down so we can move to on the 21st problem. Okay, so now I am writing down the 21st problem. Just see what is the 24th problem. Problem number 21. Problem number 21. What is the problem number 21? Problem number 21 is integral of x to the power 9 divided by 4x square. This is 4x square and plus 1 and whole to the power 6 dx. So x to the power 9, 4x square plus 1 and whole to the power 6. So now let's see how we can solve. So first step, if I want 4x square, no, to free, it should be only 4. So what should I do? I am dividing it by x square. And since I am dividing it by x square, no, so I should multiply it also. But you see, when I will divide in this bracket, no, x square, so it is actually what? X square to the power 6 here. So it is actually x to the power 12. So to balance it, what should we do? X to the power 9 here, and it should, if let's suppose I am dividing like this, and whole to the power 6. So basically I have made the changes as x to the square and 6. Now to make it balanced, no, I have to multiply here x to the power 12. Now it is balanced. Now there is nothing, no change we have done. X to the power 2 to the power 6, x to the power 12 and multiplied. Now benefit I will have is, I can write it now, x to the power 9 will cancel it, it will become x to the power 3, 1 upon x to the power 3. This will become 4x square and this will free from the x square term and 1 plus x square and dx will continue. Correct? So I will get the equation, I will get something like 4 plus 1 upon x square and 1 upon x cube. Now see, if I assume 4 plus 1 upon x square is equal to t. Now if I find the derivative of it, it will become what? 4 is what? It will get cancelled and this will become minus 2 upon x cube, minus 2 upon x cube, and this will become dx is equal to dt. Now see, dx upon, I can write only dx upon x cube as minus dt by 2. Now make all the changes. If we change, no, dx upon x cube is minus dt, so this will become what? Minus half dt will be here, and this I have assumed as t. So this will become what? Dt upon t and to the power of 6. To the power of 6 we have missed everywhere. There also. Everywhere we have missed. Now it is correct. So t to the power 6. Now this can be what? This I can write as t to the power minus 6 dt. And what is the integral of t to the power minus 6? This will become t to the power minus 6 plus 1 divided by minus 6 plus 1. So basically this will become minus 2 or minus 1 by 2 t to the power of minus 5 and minus 5. Minus and minus will become plus. So this will become half t to the power minus 5. What is the t we have taken? We have taken t as 4 1 plus x square and to the power minus 5 plus. So this will be your final answer. Okay. 2 and this, no, this 5 is there. No? So this will be basically 1 by 10. 2 5s are 10 we have to do. Only the minus and minus become plus now. This multiple should be there. 1 by 10, 4 plus 1 up x square minus 5 plus c. Correct? Is it okay? So this was problem number 21st.